Welcome everybody to Haystack Live. I'm very pleased today that we have managed to pull back from a small issue we had with our Haystack US conference. Poor Ansgar here couldn't travel to the US for the conference. So he's very kindly agreed to give his talk today as part of Haystack Live. I'm very much looking forward to that. That's going to be on personalization of search results using embeddings. Embeddings, of course, big in the news at the moment in the search world. Everyone's doing embeddings, so I'm very much looking forward to hear how Ansgar is using them at GetYourGuide. So a few little bits of housekeeping beforehand. Please do keep your mic muted just in case of background noise. If you have questions for Ansgar, please put them in the Zoom chat, and after his talk, I'll be asking them on your behalf. And we'll be recording the session, and I'll go up to our YouTube channel as usual, so that'll be up there soon. And we have, but before that, I've also got a couple of training dates there from Open Source Connections, which you can see on the screen. We've got one, the first one is Elasticsearch coming up in July, and then we've got Learning to Rank in August, but do sign up for that. But just before that, I thought it might be nice to talk about a couple of other events that have been happening recently. So if I can make my screen share work correctly. Yes, so quite a few events the last month or so. We had MICES in the US, the e-commerce search conference, first one in the US, the day before Haystack. This is Johannes Peter talking about search, showing something about the evolution of the human brain. We then had Haystack US, which sadly Ansgar couldn't make, but it was a fantastic event. We had speakers from Shopify, from OSC, from Relics, lots of other things, lots of other places. We did the search radar discussion, which was lots of fun. I think we had about 90 people online, 90 people in person, all collaborating on coming up with some kind of visualization of what are the up and coming things in search, and we're working on getting that out as an artifact, a blog post soon. But also, I've just come back from Berlin last week, where we had the Berlin Buzzwords Conference. The search track was sponsored by OSC. There's Uwe about to tell us some very clever things about Lucene. Joe Christian talking about Vespa, of course. And then we had the MICES EU conference, again on e-commerce search, which went very well. We had a lot of people for that, I think we had about 65, 70 people in the room. Lots of networking and chatting, and a huge amount of biscuits for some reason. And then a bar camp where we discussed things in a more informal session. So it's great fun. And also great fun just to get together with people again in person and to chat over a beer or two. That was very refreshing. So without further ado, I'm now going to hand over to Ansgar, who's going to talk about personalization of search results with embeddings. Ansgar.
Okay, cool. Can you hear me? Can you see the right screen? Okay. Cool. Yeah, then thanks, Charlie, for having me, for allowing me to give the talk now in this online version. I now have the US visa, so for the next conferences in the US, I can join. And I'm looking forward to that. Also, thank you to everybody for your interest in the topic. Yeah, as Charlie said, it's about personalization of search results for ad traffic with embeddings. It's one specific thing where we did a first step at GetYourGuide in the direction of using these embeddings for search results. But let me first introduce a bit the team and also the company that we work for. So the team, we had Ashraf, senior software engineer in the search team, Victoria, a senior backend engineer in the search team, and then there's myself, Ansgar, a data scientist in the recommendation and relevance team. The search team is more responsible for getting the search pages live and also for finding the right things for a query. And the relevance part of this R&R team I work for is responsible for the ranking of these activities. The company that we work for is GetYourGuide. And at GetYourGuide, we connect millions of customers to travel activities worldwide. So the products that we sell are activities like walking tours, like entrance tickets to museums, but also something more exotic, maybe like cooking classes also. Whatever you are interested in when you're traveling, it should be available. So check us out. And yeah, GetYourGuide was founded in 2008 by students in Zurich in Switzerland. Grown a lot, of course, moved the headquarters to Berlin. And the founders are still in the company, which is nice. There are still some teams in Zurich. And once I had the opportunity to be in Zurich in Switzerland, and there was a company anniversary, and I was really able to see the small first office of the company, and that made me aware of this big growth. It was interesting. We came well through the pandemic and are seeing now a big demand for travel after this pandemic, even in these turbulent times in the moment. But what might be more interesting to you is, for example, what we use as machine learning at GetYourGuide. Oh, I have to switch here. So there are quite some different components, like ranking of activities and of other components, like locations on some parts of the website. We have recommender systems, we have demand forecasting, and image AdWords optimization. So really a wide range of applications of machine learning. And this talk will concentrate on this first aspect, the ranking of activities, and I guess that's also most suited for the audience here. So let's take a look at the use case that we tackled in the project I'm talking about. It's about ranking activities for specific users which are landing on GetYourGuide pages, namely users which come from our partner sites, or at least that's one example that I present here first. One partner site could look like this. It's a part of it. We have a blog post text on top, and then at the bottom there's a widget of GetYourGuide. And if we zoom in a bit, then you see that in this widget there are already 3 activities displayed, and the user could click on it and then land on GetYourGuide. When I practiced this talk, I thought maybe I should say that I think we don't have any personalization in these widgets yet, so that you just see padding here that's not related to me as a person. But yeah, in this example, it's nice. And then there's another way how you could land at the specific GetYourGuide pages that we talk about. It's very similar. Here, actually, it's an example of the same blog post, and it's similar way is just a link to GetYourGuide. And let's zoom in a bit again. So this is a specific activity that is linked at the bottom of this blog post, the specific walking tour. And if the user clicks on this walking tour, then they land on GetYourGuide. Now, yeah, let me stress also that this is not the only way you can land on these landing pages I will talk about, but it's the best way to understand the principle. And also, this is important traffic from GetYourGuide, so it's not extremely small, otherwise we wouldn't have tackled it. But yeah, so now you know roughly how the users come that we deal with, and how does the landing page look like that they land on. It's a search results page like this. I simplified it a bit so that you're not overwhelmed. The really important part is in the middle. That's the list of the results. And the first result that you see, that is a so-called elevated activity. It has this light blue background. That's actually how it looks on our websites. And that's the same activity that the users have clicked on before. So that's the first result. And then the rest of the results are other activities from the same location, like in this case, Berlin. And let's take a look at a bit more results. Maybe I can just say if the user then, of course, clicks on this elevated activity, then they get to a detail activity page, and there they can book it, but they can, of course, also explore other of the activities. Now a bit more results to get a better overview of what is happening. So I just show here the top 10 results, how they would look like if we didn't do our change. At the top, you see this private city walking tour, the elevated activity. And then below, there are activities that in general we would recommend to a user looking for Berlin. You might detect that there are quite some boat tours. I think that's because currently in summer, they are probably well performing, but there are also other things like the TV tower ticket or this Arise Grand Show. So there's some mixture. You might notice that there's no other walking tour though. Now you know the use case. What was the general idea of the project? Actually, our colleague Ashraf had the idea, and he thought the following. So wait, the user has already clicked on the elevated activity before even arriving at GetYourGuide. So that means that this activity contains quite some information about the user intent. So why don't we use this information to improve the ranking of the activities below that? And that's what we tried to do. How could we do that? Of course, the general idea is that we rank activities higher which are similar to the elevated activity. So in the example case, we would expect that there are some more walking tours showing up higher up. And on the other hand, we don't just want to use the similarity, but we want to mix it with a normal ranking, because we still think that tours that perform better, or where our normal algorithm thinks that they would be better suited, they should also be higher up than the other ones. And for mixing this, we use a formula like this very simple one that you see here. It's a mix of the normal ranking score with a similarity and a weighted similarity, and this weight W is just a constant. If we pick a very high W, then the results are just ranked by the similarity to the elevated activity. If we set it to 0, then they are ranked by the normal. Then basically we end up with a normal ranking. And how would we calculate the similarity? So there the embeddings show up. We would use semantic vectors for our activities to detect the similarity between them. I will briefly recap the main idea. Probably everybody here knows it, but then you see it in the GetYourGuide context. And just simplify it for 2 dimensions. So here we have 6 activities on GetYourGuide and their corresponding vectors, how they could look like. The 2 dimensions are, on the one hand, the location, and on the other hand, family friendliness. And if 2 activities are similar, then also their vectors are similar. Of course, the real embeddings look a bit different. What stays the same is that vector similarity means that there is also semantic similarity. So if activities are similar, then also their vectors should be similar. And what is different is one thing that normally you don't know the meaning of each dimension, because that's just decided by the algorithm, which normally doesn't have human readable output. And then the dimensions are, of course, much more. So in our case, it's 300 dimensions, and that's because we use a Word2Vec model. Okay, why did we use this Word2Vec model? That's basically because we wanted to get this idea out very quickly. And they already existed, and they were live in our recommender systems. So every day they would be created newly, and for this project we didn't have to program anything about the vectors. I just still want to introduce the model briefly. It's a quite old model from 2013 by Google, and the main idea is that it translates words to vectors. So it's an embedding from words to a vector space, and it trains on the word surroundings in texts. And basically in training the model, it either tries to predict the hidden word from the surrounding or vice versa, and that's how it trains the vectors for these words. Maybe I could also say it only has 2 layers, so it's really first an early model for embeddings. But still for us, for recommendations, it worked quite well. And as you will see also in this project, it worked well. The basic result of this training is then that if words have similar meanings, then they have similar text surroundings, and then the model also creates similar vectors for them. Question would be, we want a vector for our activities, for our products, not for words. How would we use the algorithm for that? And that's an idea I also want to repeat because I really like the idea. It's from 2018, and to the best of my knowledge is from Airbnb. At least I found this article by Airbnb, and in the same year it was also already used by GetYourGuide. And the idea is that instead of looking at words, we look at, or instead of looking at text, we look at user journeys. There I can also give an example of a user journey on GetYourGuide. So it could be that the visitor lands on the destination page of Berlin. Here we see the upper part of it. And then the top activities that they see here might not be good enough, so they want to explore more, and that means that they go to a search page. Actually, this is a full search page, how it looks for Berlin, not simplified anymore. And then the users could be interested in this first activity, click on it, get to the activity page of this activity. Maybe you want to see something more, go back to the search page, see the search page again, and then click on the second activity, and so on. So that's one example of the user journey. So how does it look like a text? Well, it's a sequence of pages, and the text or sentence for the Word2Vec model is a sequence of words. So basically, instead of looking at words, we look at pages, and instead of looking at text, we look at these user journeys. And we really can apply the same algorithm directly, and we get a vector for each of the page. And we are only interested in specific pages, namely the activity pages, because we only want a vector for the activity. So we use the activity page as a word, and for example, for this first boat tour, we would get a vector. The analogy for above is that a similar activity creates a similar user journey, and that creates similar vectors. Okay, so that's the embeddings that we used. And now let's take a look at the implementation. At first, just a rough overview. As you have seen before, the user in this example comes from a blog post, has clicked there on a link or on an activity in the widget, and then they arrive with the ID of this elevated activity on GetYourGuide on this search page, search results page. And there now we have to display the new ranking. And yeah, that we do in two streams. On the one hand, we first get the vector for this elevated activity and get the activities which are similar to the vector. On the other hand, we get the normal search results, and then in the end that's combined, and we put the elevated activity, of course, as a first result, and then for the rest of the ranking we mix it by this weight between the similarity and the normal ranking score. And that result is then displayed to the user. So that's the rough setup of the system. Let's take a look at some details of the implementation that we did in the first version. As a search engine at GetYourGuide, we use OpenSearch, so the AWS version of Elasticsearch. And the goal of this implementation was to fail fast, or better, of course, we wanted to succeed, but we wanted to check the idea out very fast. So we wanted to get an A/B test out there very quickly, and also in a way that we don't interfere with the live system a lot. So in case it fails, that we don't have to clean up a lot in the live system, and also we cannot mess things up for other pages. And because of that, we created originally a new OpenSearch index for these vectors. And that's where we can do the lookup of the vectors. And then we basically ran the process roughly as I described before, but now I want to present a bit more details about it, and also the queries that go to the search engine. So in one step, it's a normal search. So there we didn't have to change anything. It's simplified. It's one OpenSearch query. And then in parallel, we could get the vector of the elevated activity. That's a very quick OpenSearch query in this first implementation. Basically, it's just an ID lookup, so you don't really need a search engine for that, but that's how we implemented the first version. And then with this, we did the third query, and that is really then for getting the vector similarity. So that's also on this new index of the vectors. There I will tell a bit more details below, but that's roughly it. And then comes the fourth step, step D, and there we rank by the formula that you saw before. The ranking score comes from this first query, and the similarity is the cosine similarity between the vectors, between the vector of the elevated activity from B and between the vectors of the activities that should be ranked from C, basically. And yeah, cosine similarity is the cosine of the angle between these two vectors, between -1 and 1. And this combination of the two scores that we did in the backend, so that we didn't use the search engine for, but we just did it in the end in the backend. And why this was fast enough, maybe some more details for this third step. We used the k-nearest neighbor plugin of OpenSearch for vector similarity, and a bit more specific, it's the KNN with a scoring script, because that allowed us to do additional filtering. And to be more precise, what we did in the step C for getting the vector similarities, it's not a query on this full index, but we filtered by the activity IDs from the first result. So that's why additional filtering was helpful. And with all of that, it was then fast and worked for when we tried it out, and we were quite happy with this first implementation. Question is, of course, what were the results of this? And maybe let's first take a look at the one specific example case that we saw before. You might remember there was this private walking tour of Berlin as the elevated activity. And then below there were these some boat tours and also TV tower ticket and the Arise show. So that's how it would look like today if we didn't do the change. And how it really looks like today for the same example, that's like this here. So I think if you scan this quickly, you see there are really now a lot of walking tours included. There are also some other things like boat tours, and I think there was also a bus tour was also there. But yeah, you see the influence of this vector similarity. And yeah, that made us happy when we saw that. We tried it, of course, first out offline with the vectors. And that's actually also how we decided for the first implementation on this weight W. We just looked at very important examples, but just example cases, like the ones which have a lot of traffic. And what we tried to reach is that we saw some influence of the similarity. So in this case, some more walking tours, but then also that there should still be some other activities in the top. Okay, so this is how one example looks like, but then what did the users say? As I said, we ran an A/B test on this, and you might guess by me presenting that the results were not that bad, and indeed we were quite happy with it. So we ran the A/B experiment, and the result was for once an uplift by almost 4% on conversion rate, which was significant, and also similarly an uplift on revenue, which was significant. So yeah, that was really a great result, and it's not, we don't see that with all our experiments. In particular in ranking, we have tried quite a lot already, so to get better is not so easy. But yeah, here the conclusion is clear. So the new ranking is really better for the user and also better for our business. Apart from the results here from this A/B tests, we also try to extract the most important learnings from this project that might also be interesting to you. The first one is, of course, this usefulness of semantic vectors. As I said, we have used them before for recommendations, but now also for search use cases or ranking use cases. And the other thing that I want to stress is this quick proof of concept. So we really managed to get this thing live in just 2 days with our team of 3 people. And yeah, that's, I think, really a big part of the success, what I'm proud of. And so we got an A/B experiment live very quickly. And one part how we did it is by productionalizing, so putting it in a real production-ready process fully later, so only if it's successful. The one thing that we didn't implement fully for the A/B test was the indexing of the vectors, for example. That was just a manual process still. We did it throughout the experiment several times manually, but yeah, it was good enough. And another thing that helped is that we used existing components. Yeah, one thing I already mentioned, these Word2Vec vectors, they already existed. They were calculated daily. We didn't have to do anything. Also for the calculating the vector similarity, and for this part, we could use the plugin by OpenSearch. So there we also didn't have to install anything new. One more important thing is that all needed people and all knowledge was in the team. Like in this case, from the search team and from the relevance team. And yeah, maybe to add, which I didn't put here on the slides, is also that we had the buy-in, that we really could try something out quickly. Sometimes it can also be a blocker that it's difficult to get things live because you don't have the buy-in. Another learning I would like to present here is, and that's the reason another reason why this was possible to get it out quite quickly, is that it was a hackathon project. So at GetYourGuide, this is done every 2 months for 2 consecutive days. And all the engineers are allowed to participate. Like I, as a data scientist, I am inside of GetYourGuide. We are considered as part of the engineering, so I'm also an engineer. And that really sparks creativity and new ideas. Of course, not all of that works, in particular, not after 2 days, but there's really a lot of good new things coming out of it. And it also sparks cross-team cooperation, in this case between the search and the relevance team. And yeah, we really see often impactful results either for the customer or also for internal improvements that then simplifies our engineering. Yeah, that's the most important learnings I would have for you. Finally, I want to present our next steps in this direction. And here, the first one is actually already done. Maybe the first sub-step was really done very quickly after experiment. As I said before, like this indexing of the vectors, we had to automate it, and that was really done very quickly. But then we also did a change of the system, and that is we moved this vector similarity ranking to an own service. And that's was needed because of a general restructuring of our search system, that we do this extraction part from the search engine in one service, and then the ranking part in a re-ranking service in a own Python service. And that works quite well for us. So the biggest win that I see is that actually the two teams are getting more independent. So that results in faster progress on both sides, I would say. And yeah, maybe another reason there is that I mentioned that GetYourGuide is growing, and we also recently grew quite a bit also in the teams. So the teams grew, and then it's also better to be a bit more independent. Another next step that is not done that we want to do still is to adjust the weight of the similarity depending on the context. Or maybe I could have even put optimizing the weight at all. As I said, it was a very manual optimization process. So that can be done in a more machine learning way, and then not just for one global weight, but depending on the context. We really believe that some traffic sources want to have a more overview of what exists, and others, the user intent in this elevated activity is quite strong. And there, what we plan to do is to use the similarity as an input to our new live ranking model. So this kind of model is currently tried out. It's a learn to rank model. And if that's successful, then it will be quite easy to put in the similarity as one more input. And then the model can learn from the training data where a bigger weight could be useful or where a smaller weight could be useful. Also, we have now quite a lot of attempts to use semantic vectors, in particular TourBird, which is a pre-trained tourism version of BERT. And we also tried Word2Vec, which builds vectors based on a graph. So there we tried to move the knowledge that we have about our activities into a graph and extract a vector from there. And all such attempts we try out currently, on the one hand, for ranking activities based on a query. So it's a step in the direction of neural search. And we also will start an experiment next week, if everything works well, about using such vectors for the diversity of search results. That goes in the kind of opposite direction of what I presented here, but for some pages, like general results of Berlin, for example, if the users just land with the expectation of, I want to do something in Berlin, it's better to show more diverse things and, for example, not just boat tours. So that's what we try out. It's also tried out in our search engine marketing optimization. And actually in these widgets that you saw right at the beginning in this blog post, we now try out, or actually it's a different team, and they try out to use such embeddings to detect from the text, the surrounding text of the website, which activities would be good inside of the widget. Yeah, so that's mostly what I try to present here. Maybe one thing, there's also a corresponding blog post to this, what I presented here. I will try to distribute this presentation so you could follow the link. And apart from that, yeah, thank you for your attention.
Fantastic, thanks, Ansgar. We do have a few questions already, but so for the rest of you, do think of a question and type it into the Zoom chat. So our first question, if I can just find the right window here, we have from Sujit Pal. Hi, Sujit, who asks, what happens when a user has multiple elevated activities over the course of interacting with the site? Does this go into their activity sequence and it is treated as a sequence?
Okay, so in the sequence, we actually would consider this first search result page as a normal result page for Berlin. So we didn't go into the details of calling this result page Berlin for elevated activity 1, 2, 3. So it's just treated as a normal result page. And then where we get the vector of this for each activity of is the activity details page, kind of. I hope that answers the question.
Great, I hope that helps, Sujit. So our next question comes from John Kane. Hi, John. You said you got the initial information or referrals from your partner sites. How is that data transferred to your site or platform? Is it an API, a referral, or?
It's just a URL parameter. So the only data that we get there is the ID. Or maybe actually it's, I'm not an expert on that. So, but the most important part is the ID of the activity that was really clicked on. It might be also the location, but like Berlin in this case, but we can also look that up. So yeah, mostly it's the ID of the activity.
Great, thank you. And Andreas says, thank you for the talk and refreshingly practical after this was a bit scarce in general at Berlin Buzzwords, semantic search. So you're doing better than the people at Berlin Buzzwords apparently. But Andreas, do you have a question?
Not really right now. Like, I gotta think about
And if you're speaking, you're very muted. I can hardly hear you.
All right. Do you hear me?
Still
All right. Right now, I don't have further questions. Thank you.
Okay, no worries. Anybody else have a question for Ansgar? About semantic search, the fun of getting a US visa, anything really.
Actually, I would have one, and this is related to what you said about that you're exploring a bit, like the range of like transferring information from knowledge graph to your vector search. Can you share a bit of experiences you collected there, or is this like too premature to go into?
Yeah, I can just say a little bit because it wasn't my project. I've just seen it, and so far we tried. It was actually also, it started as a hackathon project of a colleague, and the results they showed that it's actually they could get the similarity out of there. In the end, for the project where we tried to use it, it was not the best. Actually, it's for where we tried it out was for the diversity project, and there we had a kind of offline evaluation to try which vectors seem to perform best, and there even the Word2Vec vectors were still the best ones. Yeah, apart from that, I don't know what. Maybe how the colleagues tried to get a graph out of the data that we have of the activities. So they tried to, on the one hand, connect activities which are booked together, but also on the other hand, they implemented new nodes in the graph, like category nodes. So activities which are in the same category, then they are connected by one node in the middle.
All right, thank you.
Can I follow up on my question? This is Sujit. Hi.
Yeah, go ahead, Sujit.
Yeah. Thank you for the talk. It was actually quite interesting. The thing I was thinking about is that, somebody comes in through a partner site, by clicking on an event, right, that you host, right? So it comes in now, that has the blue box there, and that's the top result. But now the next thing he does is he goes and clicks maybe the third result in that search, in that search output. Yes. What happens then? Do that, in the second case, does the first and the third result have a blue box and, go up to the top?
No, this, I think I will not find the page quickly enough, but in this, the page with this light blue first activity, that's really only a landing page. So only when you come from the external partner side, then you will see this elevated. All other search results, they don't have them.
I see. Okay. So then it's all recommendations up there. Okay, got it. Cool. Thank you. That was my question. Yeah.
Great. So do we have any further questions for Ansgar? Great. Well, I think we'll wrap it up there. Thank you so much. And it's been a long road, but we finally got your Haystack talk out. And we do hope to see you in person at the next Haystack. So yeah, thank you again, Ansgar.
Okay, thank you. And thanks to everybody.
Fantastic. So we've got a couple more things just to say at the end here. If I just share my screen. So we would like some more talks for Haystack Live. So if you would like to give a talk, or somebody who could give a talk, please do go to the Haystack website and look on the light blue box and the third link there. There's a link to submitting for Haystack Live. We'd love some more talks in our queue so we can continue to bring you lots of exciting things all about search and relevance. Now Berlin Buzzwords and Mices are over, I will be starting to think about dates for Haystack Europe. This is going to be a one-day, one-track conference probably in Berlin in sometime in September, October this year. As soon as I have a date and a venue, I'll be talking about it a lot. If you want to get an update, keep an eye on the Haystack website. Also follow Open Source Connections at O19S, and we'll let you know as soon as we can. Also, it will be all over relevant Slack. But once that's out, we'll also have a call for papers, and obviously we'd love you to give some submissions about your search and relevant stories. There are a few more conferences coming up. For those of you in North America, there's ApacheCon in New Orleans in October. And I do know that Eric Pugh from OSC is talking about search. So there'll hopefully be some other search talks there as well. Do check that out. And the OpenSearch folks are running their first event. That's going to be in September in Seattle, OpenSearch Con. So do check that out. Again, you should be able to find that quite easily with a quick Google. Like most things, there's kind of conference seasons, and the autumn or fall conference season will be the next kind of block of these events, but there'll probably be a few scattered about before then. Just to remind you, we have our training courses coming up, Elasticsearch in July, Learning to Rank in August, and there's some more in September. If you're a Solr user, do check out our training courses. And of course, all of you should already be in relevant Slack, but if you're not, do jump in. We've got more than 2,600 people there, which is fantastic. And it's a real home for everything about search and relevance. So that's about it for Haystack Live this time. We'll be back, but we can only be back with your support. So do find some relevance talks and get them submitted, and keep an eye on the meetup group. Tell all your friends, tell all your colleagues, and we'll see you all again back here at Haystack Live. Thanks and goodbye.